Welcome back to section 13.3, looking at geometric and arithmetic series and their sums. Here we're looking at the sum of a finite geometric series, the formula. So we're looking at figuring out, again, the sum of the first n terms of a geometric series. Again, S sub n is referring to the sum of that many terms. T sub 1, again, is referring to our first term. R here is going to be referring to that constant ratio. So you still need to figure out what is it that you're multiplying by. And then again, n is standing for your number of terms. So looking at a problem, we really need two things. So kind of digging into this example of finding the sum of the series 3 plus 9 plus 27 all the way up to 6,561. We need to know the first term, which we know. It's just 3. We need to know as well what is our constant ratio. So the idea of 3 times what gives us 9, 9 times what gives us 27. Well, that's not too crazy because it's just multiplying by 3. So that's going to be our R value. The thing that takes a little bit more work is figuring out n. We want to know what is the nth term. Well, we know the nth term, I'm sorry. It's that 6,561. We want to know, because it's our last one, we want to know how many numbers is that, though? How many numbers do we have actually in our series? So to find that, we're actually going to use our previous information from 13.1. We're going to take our equation of t sub n equaling t sub 1 times r to the power of n minus 1, so that explicit definition for a geometric series. And so we can plug in, we're basically going to solve for n, figuring out what it is. Well, we know that our last term is the 6,561. Our first term is 3. Our constant ratio is 3 as well. And then that's to the power of n minus 1. So if we then work on cleaning this up a little bit, a couple of options. Well, we've got 3 to the first power times 3 to the power of n minus 1. So if we combine our exponents together, we're looking at 1 plus n minus 1. So really just getting 3 to the power of n. Oh, that 3 looks rather bad, I apologize. Equaling our 6,561. So it seems like we just need to know 6,561, it's 3 to what power? So if you maybe do a little bit of work on your calculators, start multiplying by 3s, I think we end up getting that 8 is equal to n. So if we're looking at 3 to the nth power, that'll be 6,561. So when we're looking at trying to figure out how many terms we have, that's essentially a quick way to find it. So now we know that 8 equals n. We're looking for the sum of the first 8 terms in this series. We know that t sub 1, our first term, is 3. We know that r is 3 as well. And we are going to the 8th power. And then from there, we're looking at 1 minus r, which is in this case 3. So to figure out our sum, we essentially have to deal with that expression there. So maybe possibly tossing this quickly into the calculator, we'll end up getting that s sub 8, so the sum of the 8 terms in our finite series is 9,840. All right, so that would be your sum, and this is your example of the sum of a finite geometric series. All right, I believe there will be one last example, so take a look at that one or start into the homework, whatever you're feeling like doing at the moment. Thanks.